Up until this point, if I were to give you a vertex form equation, so example, y equals x minus 3 squared minus 9. If I gave this to you and I asked you to tell me what the x-intercepts of the parabola were, likely what you would do is you would expand this, right? So you would write this bracket as repeated multiplication. You would use the rainbow or distributive property to expand, simplify, put it into standard form, and then you would factor, which is not wrong. It just takes a long time. And sometimes also if you were to do that, if you expand to standard form, you might find that you can't factor, so then you would use the quadratic formula, which again, like I said, is not wrong. It's just a lot of steps. So today we are going to look at how we can go from vertex form directly to finding the x-intercepts. Okay, and this is especially helpful when the x-intercepts of your equation are decimal numbers, but you can use it for any type of equation, okay? So the first step is you are going to let y equal 0. And the reason we do this is because the x-intercepts, as we know, lie on the x-axis. So the y value of their coordinate is always 0. Okay, so if we let y equal 0, that is going to help us solve for the values of x that make this true, right? So it'll help us find the values of x where y is equal to 0. Okay, so then once we do that, the second step is you are going to add or subtract the k value from both sides. Okay, so in this case, k is -9. So to undo it, we are going to add 9 to this side. We're going to add 9 to the other side as well. Okay, so we would have 9 is equal to x minus 3 squared. Your third step is you are going to divide both sides by a. And this is only if a is not equal to 1. Okay, so in this case, our a value is 1, right? There's nothing written in front of the bracket here, so we don't need to divide both sides by 1 because nothing would change. I mean, you can if you want to, but like I said, nothing will change. If there was, let's say, like a 3 in front here, you would divide both sides by 3 first and then continue on. So then once you've done that, your fourth step is going to be, you're going to take the square root of both sides, and we're doing the plus or minus square root of both sides, similar to in the quadratic formula, because there will be two options, okay? And because even though your calculator will only give you the positive version, we know that there's a negative version as well. Okay, so we're doing this because we want to undo the squared that's happening right here. So the whole bracket here, x minus 3, is being raised to the power of 2. So to undo it, we have to take the square root of this side and then the square root of this side. But like I said, what this ends up looking like is we'll have the plus or minus square root of 9. And then on the right side, when you take the square root of that bracket squared, you're just left with x minus 3. Okay, so you don't need to show the plus or minus thing on the right side. It's just on the left side where the number is. Okay, so the way that that I then write this is I know the square root of -3. So on my next line, I'm just going to write this as plus or minus 3, okay, is equal to x minus 3. And now you have two options, or sorry, there's one more step to isolate for x. So your fifth step is going to be add or subtract your h value. Okay, so whatever number is there. So in this case, I have -3 on the right side, so I'm going to add 3 here. I'm going to add 3 here. The important thing to remember, though, is the way you're going to write this is like this. You're going to write it as plus or minus 3 plus 3 equals x. Okay, don't add it to this number and say, oh, this is plus or minus 6, because that's not true. Okay, so I'll show you why. Your sixth step and the final step is to just calculate. So usually what I do is I write down I've got plus 3 is equal to x, and I have minus 3 plus 3 is equal to x. Okay, so similar to with quadratic formula, I write both options, the positive and the negative. Okay, so for the first one, plus 3, that's going to tell me that x is equal to 6. But then the other one, negative 3 plus 3, that is 0. So I would have x equals 0. Okay, and those would be my two x-intercepts. So it's important that you do the positive negative thing first, okay? Because if we had have just said, oh, this is plus or minus 3, I'm adding 3 to it, plus or minus 6. Sure, one of those is right, right? Positive 6 is right, but the other one is not negative 6, okay? You have to make sure you calculate it properly. So just make sure when you are doing that fifth step, adding and subtracting your h value, that you do it correctly and you leave it after the positive or negative number there, okay? So what will happen if you try and do this and there are no x-intercepts is similar to what happens with quadratic formula. So you will get a negative under the square root. Okay, so if we look at an example, if I have y equals 3x plus 5 squared plus 2. The first step is I'm going to bring the k value over, so I'm going to subtract 2 here. Oh, sorry, actually, first step is I'm going to let y equal 0. Okay, so I'd have 0 equals 3x plus 5 squared plus 2. Then I'm going to bring the 2 over by subtracting it. I would have negative 2 equals 3x plus 5 squared. Because here a is not 1, I would need to divide this side by 3 first, okay, because that would cancel this out. And then I also need to divide this side by 3. Then I'm going to just go over here. Then you would have negative 2 over 3 equals x plus 5 squared. And the next step is we want to take the square root of this side to undo that power of 2. And so we also need to take the square root of this side, right, the plus or minus square root. But here we cannot do that because if you try to do the square root of negative 2 over 3, your calculator is going to tell you error. It's going to tell you to keep it real. You can only square root a positive number when you're working with real numbers. And something important to note here is this plus or minus does not mean like it affects the number inside at all. Okay, so when you're typing this on your calculator, you just would calculate the square root of 2/3 if it was a positive 2/3, and then you do the plus or minus after. So this plus or minus in front does not say, oh, I can make this a positive 2 over 3 and then just calculate. No, if there's a negative sign under the square root, then you cannot do anything. So you would say, therefore, there are no x-intercepts. Okay, which again, we know is possible. So if you have that happen, just make sure you check your math to make sure you didn't make any mistakes, but it's okay for you to say there are no x-intercepts. Okay, so let's just look at one more example. So we have this parabola here, y equals negative 4, x minus 5 squared plus 36. So my first step is I'm going to let y equal 0. Okay, you do this because, again, your x-intercepts happen when the y value is equal to 0. So I'm just writing the right side, the exact same. Then my first step, this is just all like reverse order BEDMAS. So first step is to subtract 36 from both sides. I'll have negative 36 equals negative 4 x minus 5 squared. Then I need to get rid of this negative 4, so I'm going to divide this side by negative 4. That will cancel this out. Divide this side by negative 4 as well. So now I have negative 36 divided by negative 4 is positive 9 is equal to x minus 5 squared. Then I'm going to square root this to cancel out my power of 2. And I'm doing the plus or minus square root of 9. right? So like I said, you just do the square root of 9 is 3, and then you're writing plus or minus 3 is equal to x minus 5. So then the last step here is we're going to add 5 to this side, add 5 to this side again. I don't write it directly below because I don't want to add it to just that value of 3, right? I need to have plus or minus 3 plus 5 is equal to x. Okay, then over here, I'm going to show both of my options. So first option, I'm just going to reorder this, like flip the sides of the equal sign. So x is equal to negative 3 plus 5 is my first option. My second option would be x is equal to positive 3 plus 5, and then I'm just evaluating. Okay, so this would give me x equals 2, and this would give me x equals 8. Okay, so in both of these examples, we got nice whole numbers. It's okay if you get a weird decimal number. Okay, it's similar to with the quadratic formula that happens sometimes. So don't panic if you get those numbers. And again, you can write them like this, x equals and x equals, or you can write them as a set in curly brackets like this, whatever you prefer. Okay, so that helps cut down some time when we are given an equation in vertex form and we want to find the x-intercepts. It just, yeah, like I said, saves you a lot of time and is especially helpful if your x-intercepts end up being decimal numbers, because then you don't waste time expanding and then having to do the quadratic formula. You can do it all in one go. You would just get decimal numbers here. And the nice thing is you can always go back and check them, right? So you can plug them back into here. You can calculate using the proper order of BEDMAS and you will get 0 or close to 0 if you had a decimal number that you rounded. And that is how you go from vertex form to finding the x-intercepts.